Okay, we are now moving on to lesson 2.3, part 1. We're going to start by just solving two-step equations. Okay, golden rule of algebra. I will say this again and again and again. Do unto one side of the equal sign as you will do to the other. Okay, whatever you do to one side, you have to do to the other. Like terms are any terms with the same variable and exponent. You guys have done this before. We're going to talk about combining like terms. So we're going to go ahead and look at 4x squared and label some stuff. Hopefully we know that 4 is the coefficient. We know that 2 is the exponent, and x is the base. We can only combine terms with the same exponents and bases. Okay, that is very, very important. We can only combine terms that had the same exponents and bases. So we're going to tell whether the following are examples of like terms. 3x and 4x. Well, it didn't say anything about the coefficients. The coefficients can be different, okay? But the variables need to be the same, okay? X and x are the same. We have the same bases. And the exponent for x here is going to be 1, because there's none there. And the exponent here is going to be 1. Therefore, yes, they are examples of like terms. Number 2, we have a 3 and a 10. That's fine, coefficients. We have x and x as the base. Okay, that's good. But looks like we have squared as an exponent here and no exponent here, which means that these will not be able to be combined. They are not like terms. Number 3, we have negative 6y and negative y. Just so we remember, negative y is the same thing as negative 1y. Okay, if there's ever just a plain variable, you can always put a 1 in front of it if that helps you out. So you have negative 6y and negative 1y. Those both have y as an exponent or as a variable and no exponent, so those are good. 3ab and negative 6ab. They have the same variables and their variables have the same exponents, so we're good. Negative 16 and 9. Well, negative 16 and 9 both do not have any variables, so they can be combined. And the last one, 7x to the third and 1/9, x to the third. Remember, our coefficients do not necessarily tell us if we can combine them. What tells us if we can combine them is the variable and the exponent. In this case, we have the same variable and the same exponent, so they can be combined. Now, how do we combine like terms? Okay, so the directions are going to tell us to simplify. In order to simplify, they're just asking us to combine like terms. So, in this case, we have 3x plus 2x. You're always going to keep the variable and exponent the same, but add or subtract those coefficients. So we're just working with the coefficients. So 3x and 2x, well 3 and 2 is 5. The x's stay the same. Negative 2y minus negative 4y. We know that minus and minus changes to a plus. So negative 2y plus 4y, well negative 2 plus 4 is 2, and we leave the y's the same. Now we have 3 over here. X, negative 4x, and negative 3x. Well, those can all be added together because they all have the same variable x. X and negative 4x is negative 3x plus negative 3x. I take it one step at a time. Then negative 3x, and then I'm adding more negatives on. So I'm going to be further into the negatives, is going to be negative 6x. Let's go ahead and skip on down to we'll go ahead and do number 4. If you're presented with problems that have more than one set of variables in it, go ahead and identify which terms you can combine. In this case, I can combine anything that has just the y in it. It doesn't look like I can combine anything else because there are no other terms that just have x's in it, and there are no other terms that have x and y in it. So in this case, I can combine y, y, and 5y to get 7y. Everything else is going to stay the same because nothing else can be combined. Last one we're going to look at is number 5. Number 5, we can combine 5x squared and negative 7x squared and 4x squared. Looks like we can also combine 4x and negative 9x together. 5x squared and negative 7x squared is negative 2x squared, plus 4x squared is 2x squared. Then we have 4x and negative 9x, which is going to be negative 5x. Moving on to multi-step or two-step equations. When solving two-step equations, decide what is happening to x. So I always say make a list of what is happening to x and then do the reverse opposite or do the inverse operation. So for example, number 1, first we want to decide in the order of operations what is happening to x. What's the first thing happening to x? In this case, the first thing happening to x is that it's being multiplied by 9. Then it would be subtracted by 11. So instead of going times 9 minus 11, I need to do the reverse opposite of that. I'm going to add 11 and then divide by 9. So we have 9x minus 11 equals negative 38. And we said our x is being multiplied by 9 and then subtracted by 11. So in order to do the reverse opposite, first we need to add 11, simplify, 9x equals negative 27. Then we need to keep isolating and divide by 9. Remember, whatever you do to one side, you have to do to the other. These cancel. I'm left with x equals negative 3. Let's go ahead and look at number 7. Let's decide what is happening to x. In this case, it's being multiplied by 7, then added by 6. I need to do the reverse opposite. So instead of adding 6, I need to subtract 6. Instead of multiplying by 7, I need to divide by 7. So we have 160 equals 7x plus 6. So again, instead of adding 6, I need to subtract 6, which I get 154 equals 7x. And then instead of multiplying by 7, I need to divide both sides by 7. So I have 154 divided by 7 is 22. Let's go ahead and do number 3 and 4, and then we will be done for this video. Number 3, what is happening to x first? The first thing that's actually happening to x is that it's not being multiplied by 6, but it's being multiplied by negative 6. Okay, well then what is happening? We have a 32 here. Okay, keep in mind that I said it's being multiplied by negative 6 because order of operations would always tell me that it's going to multiply first before it does any addition or subtraction. Well, now we have a positive 32 here. Reminder that the negative belongs to the 6 and not to the 32. So we are technically adding 32. Now in order to solve this equation, we need to do the reverse opposite of this. So instead of adding 32, we need to subtract 32. Instead of multiplying by negative 6, we need to divide by negative 6. So I'm going to rewrite my equation. 32 minus 6x equals 53. First, instead of adding 32, I subtract it. And I get negative 6x equals 21. And then, from here, instead of multiplying by negative 6, I'm going to divide by negative 6. Whatever I do to one side, I have to do to the other, so I have to do it to both sides. And I get that x is equal to 3.5, negative 3.5, or negative 7/2. Last one we are going to work through is number 4. First thing, what is happening to x? It's being multiplied by 3/4, and then it's being subtracted by 11. Do the reverse opposite. So add 11, then divide by 3/4, which hopefully we know is the same thing as multiplying by the reciprocal. So we have 3/4 x minus 11 equals 16. So we add 11, 3/4 x equals 27. Then instead of dividing by 3/4 x, which is ultimately what we're doing, it's the same thing as multiplying by 4/3. These do some canceling. From here, 27 over 3, that becomes 9. So x equals 9 times 4, which is 36.